And there are times when you'll do that as well. And as we practice and play with them, we'll see. Well, I'll get us a couple where we can do that. All right. So to add this, I'm going to type. So I just went back to the do lists, the list of my commands. I selected my SEM code, and now I'm going to add comma.
It's like
Covariance E dot M3 star E dot M4. I think it's covariance. It might be covariances, but I think it should run anyways. All right, so let me leave that. Let me leave that there. Fingers crossed. Yep, that ran. All right, so I typed comma, because so once I've given the model, all the additional parameter changes are separated with a comma. Covariance E dot M3 star E dot M4. So let me walk us through the rest of the output. And hey, looky there. We've got a stronger model. So now notice our degrees of freedom went down. So it went from 42 to 41.
Can you go back up to the top
Yeah.
for 1 second?
Yeah, of course.
Sure I wrote it.
Yep.
I keep spelling things wrong. So. Okay.
So make sure you got the comma.
So it goes, yeah. Comma,
E dot M3 star E dot M4.
That little dash.
That's not part of it.
Okay.
Yeah, that just means, yeah.
Okay. Thank you.
Mm-hmm. All right, so I'm going to scroll up again for one thing because I wanted to get, there was something I meant to write down and I forgot. So 42 and 96.44. All right, so now I've got, let me scroll down to the very bottom to get my, so now I have 41 degrees of freedom with the value 66.29, and my chi-square is 0.0074. Now, if I take those values, let me bring up Excel. If I take these values, so we've got model 1, model 2, we've got the degrees of freedom, we've got our chi-square. So model 1's degree of freedom was 42, chi-square was 96.44. Model 2 is 41 degrees of freedom, 66.29. If I look at the difference between these, I get 30.15, which was pretty close to the value it said it was going to be. So I look at so there it is. Maybe one of them was there. Okay, so delta. So the change from model 1 to 1 from 1 to 2, the change from 1 to 2 is 1, and the chi-squares are 30.5. I can actually calculate the p-value for this. Chi-dist, 30.15, comma 1, the degree of freedom. And lo and behold, what I get is a statistically significant. So this is the function that generated that value. So it's very useful, you'll find, when you're doing these analyses to make the changes, is to keep track of your chi-squared and your degrees of freedom. Because this is the next test. This is the hypothesis test to determine if two models are similar or not. So null is that sigma 1 theta equals sigma 2 theta, meaning the model covariance matrix for each of the corresponding, technically it would be 1 and 2, each of the corresponding parameter estimates is the same. In other words, it doesn't really matter which of these models I use because they're the same. The alternative is that they're not the same. So if they're not the same, then one of them is better. And it's always going to be the one where you've estimated more information. Now, this is the other test that we have available. We're going to come back to this one We're going to come back to this one in a moment. Because I kind of knew this was going to happen anyways, because I looked at the Lagrange multiplier test. See, that's the power of that one calculation. It does one matrix calculation, and it gives me all the possible changes I could make. One at a time, granted, but that's still the case. All right, so let me go back to, let's go back to our output again and spend a little bit of time walking through this. All right, so still all of my parameters are coming up as significant, so nothing to worry about there. It's estimated, wow, that's actually not a small correlation. So EM3 and EM4, now we've got to step back and say, okay, wait a minute, can we justify this? Can we justify this? Well, it turns out that 3 and 4, 3 is father's highest academic achievement, 4 is mother's highest academic achievement. So those seem like they should be, it's still a measure of the home climate, but it makes sense that they would be just a little more correlated than might be predicted. So it's okay to include this, not just because it statistically helps us, yay, but we can't rely on that alone. We need to go back and justify it somehow.
I also read that if you have, like, similar to that, if you're taking, like, 2 subscales from the same questionnaire and treating them as different things, that would
that could cause them to correlate, yep. Or if you're doing the same subscale, you're doing same measures over time. Each individual item would actually have a potential carryover in the error correlations. All right, so let's
still go and do them one at a time.
I'm sorry?
If you were doing like the time.
Yeah, it's common to actually just let all of the
You just go ahead and assume all of them.
Yep.
Instead of doing them one at a time. Okay.
Yes, in that case, usually there's a theoretical justification to have the errors correlate. The idea is if at time 1 you're overestimating, it's your error estimate is an undercalculation. Sorry, the predicted value is an underestimation. The likelihood that it's going to remain an underestimation over time is pretty reasonable. Let me run the E-stat so I put E-stat M indices. I'll run that one. Okay, so this was the command that it just ran. I'll scoot this down so I can see it. Now again, I cheated. I just grabbed it from the command line. And the modification indices now are, again, I'm seeing, say, the highest one is A3 to B, which is strange, but A to B is still showing up. A to B is still showing up. Measurement A to B1, that's kind of curious. So there's A3 and B, something's happening there. Covariance. My largest value definitely appears to be EA3 interacting somehow with EB1. So my gut reaction when I look at this is it's saying, look, EA3 and EB1 appear to be, it's saying if you allow those to be correlated, there's a connection. But when I look up here, this is not as high. It's 17 versus 22. A predicting B, that could be accounting for that connection that I'm seeing in A1 to B3, or sorry, I think A3 to B1. Theoretically, this is a good example because this is where I'd say, well, let's go back to our model and put that path in. Let's put the A to B. So right now I'm running a true mediation model. Let's change the model so we add the A to B, the direct path. So I'm going to add the direct path into the model. Now, I don't know how you guys are feeling about this, but this is one of those things with Stata. And even if you're using drop-down menus, once you've got your commands in the command list, you don't have to keep going back through dialog boxes and dialog boxes to get back to them. So I'm not trying to sell you on Stata or anything. I only have like 7,000 stocks. That's it. It's not a lot. I'm not invested in Stata just yet. But if I were to, that's what I invested in. All right. So I'm going to add A to B, and let's run this one. And sweet, look what I've got now. Chi-square is 40 degrees of freedom with a value of 49.67. I can stop. 0.14. That means I don't reject my null hypothesis that my model is different. I'm sort of golden now, just because. Let's look at the goodness of fit stats. GOF, comma, stats all. Is that right? Make sure. Yeah, that's right. I'll scooch this up so you can see what I just typed. So E-stat, comma, GOF, goodness of fit, comma, stats all. Oh, I'm not sure if you saw, those of you that saw the stuff I loaded for the lecture last time, I remember what it's called. It's Hertler's critical N. The whole calculation I spent the whole class building up to, I forgot the name of it. But I remembered it and found out. So it's Hertler's N is what it was. So this gives me a 49.667, p-value of 0.141. That's great. Ramsey is small, less than 0.05. I'm good. CFI and TLI less than above 0.95, so we're good. SRMR less than 0.05, again looking good. So all in all, we're seeing a pretty good model. So let me go back to Excel for a second, because now I'm going to take this. So this was model 1. Let me move this down here. Yeah.
Something's wrong with my.
Yep.
E-stat, GOF,
Comma.
Stat, not stats.
E-stat.
Stat. There we go.
E-stat, and then it's stats all.
Okay.
Yep.
I put S's on both of the stats. All right.
Great. Okay. All right, so now let me copy model 2 down here as well. And model 3, so model 3, the one we just did, was 40 degrees of freedom with 49.67. Now, it is important to do this because if I go back, let me bring up Stata again, and let's look at the output. Let's look at the path from A to M is significant. A to B is significant. M to B is significant. So I have significant paths. But the key is to remember, when you have a significant path added to a regression, that doesn't necessarily mean the model you've explained a statistically significant amount. That's why this in Excel is actually important. Now, again, we kind of knew ahead of time that it was going to be okay, but if you notice, it's not the same number that Stata gave us. Stata said it would be about 17, so you always want to check it. So the model 2 is my true mediation model with an error correlation. Model 3 is a partial mediation model. Because this is statistically significant, I reject the claim, I reject the null that says sigma 1 equals sigma 2. I reject that and I accept that the mediation model, the partial mediation model, is the better choice. So the partial mediation model is the better choice. And it was statistically significant. Now, be aware, it can go all 4 ways. The model could be statistically significant, but the path isn't, which is tricky, because essentially it's saying, look, it's different, but it's a small effect. It could be the model's not different, but the model's not statistical, but the path is, which says you're probably looking at a multi-collinearity issue. And in this case, they're both significant, so we're kind of golden. It could also be both not significant, in which case it doesn't matter.
What is this called?
This one? So this is the chi-square test for model comparison. So this is the chi-square test for model comparison. And if I go back to my PowerPoint for a second. So what we've done now, so we can check off. We did the model check, the absolute measure. We've talked about the hypothesis tests for the parameters. I just realized it's not hypotheses, it's hypothesis tests. Now, we just did the modification index, but that's also the test that we use for the nested models. So that's also the test that we use for the nested models. And that's where you subtract your degrees of freedom, subtract your chi-squared values, and one of the nice things when you add or subtract chi-square distributions, you just get a new chi-square distribution. Okay? So that's why we can take advantage of that. We're not ready to talk about group comparisons, but we now could talk about non-nested models.
So the partial mediation model is nested within the full mediation
Yep.
model.
Yep. And the way we talk about nesting